The Apollo computers are manufactured by the Raytheon company in Waltham, Massachusetts. The computer itself consists of two trays, one containing logic modules, the other memory modules. To learn how these modules are put together, we talked with Mr. Jack Poundstone, Raytheon's Apollo engineering manager.
In this room, John, we run all of the electrical components through a screening and burn-in process. You know, there are over 30,000 parts that go together to make this machine. Now, every part is put through an electrical test and then a series of environmental stresses. Now, as an example, this girl is placing the micrologic units into a fixture that will be used in this centrifuge. Here the fixture is spun at a very high speed and 20,000 Gs of force is placed on each component.
That's a lot more than it will ever experience, isn't it?
Yes, that's true, but we put more forces on, more stresses than we really expect to ensure the high reliability.
So this is really sort of a torture chamber.
That's right. In addition, we run all the parts through a leak test to make sure there's no leaks in the can. The part is put into a high-pressure helium tank, and if there is a leak, the helium will be forced into the can. Then we put it in a vacuum chamber and evacuate and test for the amount of helium coming out.
I see.
In the final phase of the screening and burn-in process, the girl puts the parts, as she's doing here, into a test socket. Then those parts are placed on this burn-in rack. Here they will be operated for almost a week at a over voltage stress condition.
You actually are operating them.
Yes, we're operating the parts. Now, any failure, any significant failures of any our test is cause for rejection of the entire lot of 5,000 parts. After we've ensured that we have good components, then we want to make a module. Now, the little cans here are placed in these holes in a component holder. Then we take a matrix, which is a complex wiring pattern. It's placed on the back, and the wires are folded over and welded to the leads of the micrologic unit itself. I'd like to show you now how we make a matrix. Here we see an operator who is placing a piece of mylar insulator that has adhesive on both sides, and this insulator has previously had a pattern of holes punched onto it. Now this is placed on this longitudinal wire winder. Now as the piece advances, strips of nickel ribbon are laid down in a longitudinal direction on the mylar. Next, it's taken to the vertical wire winder. Here the operator is placing it on the machine, and as the drum rotates, wires are laid down on the opposite side of the mylar in a vertical direction. The wires will be laying down right over the areas where the holes have been punched.
Some running one way on one side and others running the other way on the other side.
That's right, John. Now the next operation is to perform the welding. This is done on a automatic welding machine. This machine, we are advancing the matrix underneath these weld heads, and whenever a hole appears under a weld head, the weld is commanded to drop and perform a weld, and this makes a feed-through connection from one side of the insulator to the other. Now, in the final operation, this girl uses a cutting tool to remove the excess pieces of wire to give us the final configuration of our precise wiring pattern.
This matrix, then, is the wiring that sort of connects one little microelectronic circuit to another.
That's right, John. This wiring diagram shows you how the matrix can be used to interconnect the micrologic elements. See here, a wire will run from this can down here where it's welded through to the other side, run down, break out to another can, and up here to another.
Let's see here.
Now, after that operation, the operator can now take the matrix, fold it, and cement it to the component holder. Then the little micrologic elements themselves will be placed in the holes, and we're ready to bend the wires down and make a weld. After completing that operation, the entire assembly is then put into this metal header. Now this header provides the structure for the assembly, and it has a row of male pins here, and the leads from the matrix will be welded to the pins.
So that one logic stick can be connected to another one.
That's right. Let's take a look at how the operators do this operation in detail. This operator is loading the little micrologic elements into the component holder. Note that she takes each one and dips it in a little adhesive before she puts it into the holder.
I see, so it's really fastened in place.
That's right, John. Now she's ready to weld the wires to the leads coming out of the can.
So you don't solder them, you actually weld these wires.
Those are welded. Now, she takes her little pair of tweezers and properly aligns the wire to the tin of the can. When the alignment is right, she then makes the weld. Now, that little flash you saw there was when the weld was actually made. After that matrix welding is completed, she's ready to place the assembly into the header.
So it actually does fit in that little space.
Yes, she very gently forces it in, and she's ready now to weld the matrix wires onto the pins of the header. Upon completion of that operation, we now have an electrically completed module. A test man will now take this module and run an electrical test. He plugs the module into a special test socket, and then this special piece of equipment will electrically energize all of the circuits to ensure that they are properly working. The information for the test is stored on a piece of paper tape.